Can anyone respond? Am I audible?
Yes, sir.
Okay. Okay, so we will start in let's say 2-3 minutes. Let some more people join. Okay, so let's start. Uh, hello everyone. My name is Rijal Mukherjee, and I will be taking this live session for NPTEL course on programming in modern C++. Uh, I'm a research scholar at IIT Kharagpur, and this session will be interactive. Please feel free to ask any question. So I have like you can turn on the mic and ask whenever you have any doubts. So this session will mostly be on the topics which has been covered on week 2 for this course. Also, like last week, many were asking doubts for the assignments that are being done. So I will like first 1 hour I will be solving like the questions which I have gathered. After that, uh, like we will discuss the solutions of last week. So we will start now. So this is the first question. So like this week we have you have been like this week's curriculum has had the courses in the course had the thing called function overloading. Also the you have studied the concept default arguments, right? So this question is based on that, like so you need to find out, like here 5 prototypes has been given. So you need to find out which of them are valid if when used as a pair. So you can see there are 4 options given. You can see there are 4 options given, A, B, C, D. So you need to find out which of them is or are valid. So option A is P1 P3, option B is P2 P3 P4, option C is P1 P2 P3 P4, and option D is P2 P3 P5. So this week's you had studied this function overloading and default argument concept. So we will be using those to find out which of the pairs are can be used and cannot be used. So let's first consider this one, P1 and P3. So P1 and P3. So what is P1? P1 is int n1 equals to 0 n2, and P3 is double add double equals to 0 double d equals to 0. So like is this one valid? So what is the problem with this one, P1 and P3? if we use that as a pair. So the P1 and P3, the problem is when you are using this and this, you see P1 has a inbuilt problem. So if you have declared this one as a has a default argument, then all next has to be a default argument, irrespective of whether you are using it at the later end or not. So this one is actually not valid. The reason, you know the concept. If the first argument has a default argument, then the rest all of them have to be default argument. So P1 is not valid. Okay, so next is P2. Is P2 valid? P2 is valid. There is nothing wrong in this declaration. Now let's look at P3. Is P3 valid? Yes, P3 is also valid. There is no problem in this. Double add d is equals to 0, d is equals to 0. Both are valid declaration. Next, P4. What about P4? Is P4 valid? P4 is also valid. You can use this. int double int equals to 0, double d is equals to 0. This is also valid because once you have defined this, all the rest needs to be valid. Now let's come to P5. Is P5 valid? No. Why no? Because here you have declared one has a default argument. So if this one has a default argument, then the next two also has to have a default argument. But as you can see, N2 don't have a default argument. So this one is not valid. So which are the remaining three valids? P2, P3 and P4. So the correct answer is B. P2, P3, P4. Any doubt regarding this, you can ask. If you have any doubt, you can ask. Then I will move to the next one. So the concept here is basically default arguments. This one is the thing you need to remember. So once one argument has been declared as a default argument, then all the ones that are left to it has to be right to it has to have a default argument. Else that will be a compilation error. So let's move to the next one. So again we have been given a prototype of function add. So you need to find out which of the above pair of prototypes is ambiguous and illegal as per the rule of function overloading. So which of the following pair, so we have been given few pairs. So when used as a pair, which of the following are illegally, they cannot be paired together. So if you notice here, P1 is valid, right? P1 has no problem of the prototype. This prototype is valid. Similarly, P2 is also valid. Both have been given a like default arguments. Similarly, P3 is also valid. Again, same concept. Both have the default arguments. P4 is also valid. Default arguments are present. P5 also valid because all of them have default arguments. Now I need to find out which of these pairs are illegal. So now first consider P1 and P2. So So is there any issue with in between P1 and P2? Is that valid? Is P1 and P2 valid if you when used as a pair? It is valid because you see this accepts only one integer. So when you give add suppose 3, it will always call P1. When you give add nothing, it will call P2. When you give add 3 comma 4, it will call P2. So P1 and P2 combination is valid. Now let's come to P2 and P3. So what is the problem between P2 and P3? So what is the problem between P2 and P3? So in P2 and P3, you have the same definition, but we are overloading with different return type. Is that okay? So suppose if I call add with 4, so which one will get called? It is ambiguous, right? It is ambiguous. So when I do an add 3, so which one it will go? Both of them, it can go to any one of them, right? It doesn't like when you don't specify which one is the other one, so how it can go? Obviously there rises the ambiguous, like this one and this one is okay, but this one has the same one. So if we give 4, or suppose if we give nothing, we just call add, the resolving it is difficult. So this one is not valid. Then P3 P4, what's the issue with P3 P4? Again same thing. When I call it with int4, so both of them have similar one. So this how to resolve the first argument, which one to go? It will become difficult to understand. So we cannot choose that one. Now P2 P5. P2 P5. So what is the issue with P2 and P5? Again same. So when I put int like add with one argument, which one will get resolved? Now it is still getting ambiguous, right? So this one has one argument, so and this one has two arguments, so it is okay up to that. But when you give no arguments, which one will get called? It becomes again ambiguous. So this one is also ambiguous. Okay, somebody was saying about the first one. So in case of first one, P1 is add 4. So add int n1. Yeah, this one also have same problem. So this one is also ambiguous, because if we call with one argument, suppose 4, so it becomes difficult which one to choose, this one or this one, because both has the same structure. So in this case, all are ambiguous. So you can see that due to the overloading and the presence of an uh, of the default argument, it creating a lot of havoc. So in this case, all of them are ambiguous. Shall I repeat this one again, or it is clear? Yeah, okay, I'm repeating again. Okay, so which of the above prototypes is ambiguous and illegal as per the rule of functional overloading? So you see, if we use P1 and P2, what is the signature of P1 and what is the signature of P2? Is there any way to so let's consider this case, add 4. So in this case, you see which one will get called, this one or this one, P1 or P2? See, it is ambiguous because P1 will get called naturally, but this will also get the if the signature also matches with this one, because it will assume that this argument is not there, this is a default argument, so it can call it as add 4 comma 0, it can identify it as that. So that is a reason that this one is also, this one ambiguous. So P1 and P2 cannot be used at a time. So this one is ambiguous. So same goes for P2, P3. So if you check P2, P3, here there is a different argument type. Like the second argument is double int and double, but consider the first one only. If we put add 4, which one will get called? It's a problem, like which one, this one or this one, both have int. Or suppose very simple case, we just call add, which one of them will get called, because both of them has default argument. And other than that, the another problem is we cannot overload based on the return type. So this one is also ambiguous. So then let's go for the third one, P4, P3, P4. So obviously the problem lies same. So it may have the two arguments like int 0 and double 0, but again the same problem will arise. So what will happen in case of add 4, right? In case of add 0, any one of them can, like only add, so any one of them can get called because it has got default arguments. So this one is also ambiguous. And the case of P2, P5, same, just think about this condition, add. If we call it with just add, this one has also the correct signature to get called, this one also has the correct signature to get called. So in that case also it is ambiguous. So this all prototypes cannot be used. So in all of them, just think about these conditions, add, only add, and add 4, and just verify each of them whether there is ambiguity or not. In all of the if you use this to all, you will see that it is difficult to find out which one will get called. So these all definitions are ambiguous. Okay, I'm sharing. I forgot today. Sorry. Check you can join it using it or not. So you can use this link to check the doc. Okay, so is this one clear? Unable to open. Let me again check. Now I guess you can join. Okay, so let's go to the next one. So this is the third question. So the code segment is given. You have to find out what will be the output, or if there is an error. So what you have in this case, it's same kind of definition problem. So you have 4 definitions of add here. Now we call it with add 1020. Okay, so what will be the issue in this case, or what will be the output? So will so which one will get called? Will this one get called? Because there are two, both are integer one. So will this one get called, or this one will get called, or this one will get called? Which one will get called? So again, it's bad use of function overloading. So when you have to use, so so you see again the same issue. So 10 and 20. So which one? This one also can have the same signature. This one also have the same signature. It can assume that the third one is a default. Since the third one is a default argument, it can think that, okay, only one argument missing, so I can also be the one this call has been referenced to. Same goes for here. 20 can easily be typecasted to double. So the issue is same, that all these three share the same signature with respect to this call. Right. So the issue is the compiler will get confused which one to call for this one. So as a result, it will be a compilation error. And so these are basically examples of bad use of function overloading. So when you are using overloading, You need to use it properly. This kind of coding is basically bad coding. So I understood it. It is just a continuation of the previous one. Like if you have understood the previous one, this one is easy to grasp. Okay, so let's go to the next one. So you have this code segment, and you have to fill the correct option here such that the output is 11 11 20 20. So this will be the output. You have to fill this blank portion. So let's consider each one of them one by one. So first let's consider A. What will happen if it is int 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 cr int I? So basically what is happening here? So we are passing x to here, if in this case, so 10 will be passed and 10 plus plus 11 will be returned. So in this case, if 11 is returned, so what is this? This is reference symbol. So whose reference we are storing? We are storing the reference, because in this case this I will be it is a basically, in this case it is a pass by value. So it will be some temp value whose it is being referenced. Okay, so in that case z will contain 11, x will be 10, y will be 20. So in that case what will be printed? 10 11, because 10 value is not getting incremented. See, we are passing by value. So so this one will not work, because in this case the first two output will be 10 and 11, because the passing in this case is by value. Now let's consider the next one, int cr. So in this case the pass is by reference. So our reference of x in that case will be passed. So any change in value here will be reflected here only. So in this case, what it will be storing? So the first will be printed as. So in this line, what will be printed? Yeah, when we are using this. It will be printed as x is getting incremented here, and that value will be reflected here. So 11 will be printed. Now in this case we are passing y. We are incrementing like we are passing x, and whatever is returned, that is being copied here. So what is being returned? Something is being returned. So in case of increment x, we are passing that temp value, that some temporary register we are passing. X value in this case is not getting upgraded, because it is returning a value. See, it is returning a value. So in this case the value of x in this case will not be updated. So it will print 11 and 20. So this will be the output for the case B. Now for the case C, see, there is one problem here. We are passing a constant reference. So what happens? So this will be an error, because we are incremented that constant reference. That cannot happen. When we are passing a constant reference, that increment cannot work because it is constant. So this will be a compilation error. Now consider this one. So we are passing a reference and we are expecting to get a reference from here, from this function. So this return will be a reference, not a value. So the first one will always again be 11 11. But since in this case we are passing a reference, so whose reference we are passing? X, and X only we are returning. So that means a reference of X only we are getting here, and that value is updated by the value of Y. So what will be the value stored at X? Now it will be 20. And what is the value already stored at Z? That is 20. So this will be the output in this case. So the correct answer is D. Case B will give an error because we are not returning a variable or a reference. The value we are yeah, that's what I said. Like it will not work because in that case we are returning a value, not a reference. And true, and to hold we need a constant reference. Yes, the second one, that's why the second one is third one I said it will be an error. Case B, what you are saying is correct, that it will give an error. So either it will give an error or it will not function, because in that case we are not returning a value, not a reference. Same goes for A. But I'm just showing that what if that is not given as an error, what will be the possible value that will be displayed? Because in that case we are not passing a reference, we are passing a value, a temporary value, right? So 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 if I just write it correctly here, int ampersand incr int ampersand I. So in this case we are returning also a reference, and the function also gets a reference. So while we are passing x a value of the reference of x, we are also getting a reference of x only. So that is why in this case the output will be this, this 11 11 20 20. Any doubt you can ask regarding this? It's little bit complicated, but the safe way of just remembering this is, so whenever a reference has to be accepted, you need to understand that a reference had to be passed, has to be returned from that function. Otherwise, that will not work. And to change the value here, any change in value that is done here should be reflected here. We need to pass a reference. So this is the thumb rule to understand, like, pass by reference and call by reference. Okay, so let's go to the next one. So you have been given this code segment. What will be the output? So like this week you have come across these two terms, macro and inline function. So this is a macro and this is a inline function. So what happen in these cases? What happens in cases of macro, and what is the difference between a normal function and inline function? That is a like the concept which you need to like understand first. What is the difference between a function, normal function, and an inline function? Anyone?
Sir, hello.
Yes, you can say.
Sir, inline function execute in a faster than the normal function because it has only like one statement or one command in it.
Uh,
And
okay, so okay, a faster thing is all right. Like the core concept for which inline function is used is because, so suppose it is not, it is a normal function in case, not an inline function. So what will happen here in this case? We will do a this pass by value, then this one will get computed, then it will be returned. So basically the control will travel from main function to this function and then return back. But when we are using an inline function, this does not happen. This execution happens inside this main only, no need of this transfer and all. So as a result it makes it fast. Generally, typically inline function are generally those whose length are like 10 lines at max. So if you are using a loop inside an inline function, it will not become inline. It will by default become a normal function. Same goes for any switching statement like a switch case, anything. So that is the main difference between an inline function. To make the concept is to just make it fast, and where this kind of stack exchanges from one to another doesn't happen. So, and how does a macro work? So macro works in the sense it is a like it is a compile time copying. Okay, so whenever CPP like compiler finds there is a double like macro, it will simply paste it here without thinking what is there or not. So what will be the output in this case? This case and this case. So as macro works like this, so what will happen in this case? So when we write this to you, double 10 plus 10, it will become 2 into 10 plus 10. So that is 20 plus 10 equals to 30. Simple copy. These bracket and all just forget. It is here only x written. So this will get substituted in this x part. Okay. So it will be 30. And for this triple, now this is a function, so it will act like a proper function. So when you call a function, first this addition will take place. So we will basically be passing triple 20, and that will become 3 into 20 60. So this will give 60 and this will give 30. So the correct answer is B, 3060. A is not correct. This is the reason. Now to get the correct output, that is A, what modification we need to do? If anyone can tell. So what modification we need to do so that it actually gives 40 and 60 as an answer? So you need to define the macro as 2 into x. So you need to give a bracket. If you give a bracket here, it will become, so basically this 10 plus 10 will get copied to 2 into 10 plus 10, that is 2 into 20, 40. Yeah. So no, you need to give this only this bracket. If you give this bracket, it will be correct. See, macro is a C concept. No need to use it in C++. You will in C++ you will use inline. Macro has this kind of pitfalls, so that is the reason nobody uses macro. Uh, and if you have to use macro, you need to be very safe that it is not causing any error like this. Like, error in the sense this is syntactically fully correct, but programmatically it is wrong how you are using the macro. So it is in C++ always use a inline function. Clear this one? Okay, so let's go to the next one. So you have been given this code segment. So you need to find out what will be the output. Again we have a macro. Now this is not a demonstration of, like previous one was a demonstration of why use a macro and what is the difference between macro and inline. So this is the difference between why not you what is the difference between a macro and a constant integer. Like what are the why use a constant integer in case of instead of a macro, which is a C concept. So let's approach this the same way as we approached the last one. So what will be the value of n1 if we use this? So c1 is basically 10 plus 1. So 10 plus 1 will come here multiplied by 100 and this one has come as 11, because this is an initialization and this is a macro declaration. And this is a initialization. So it will compute to 1110, and n2 will be c2, that is 11 into 100 into c1, that is 10 plus 1. Again due to the priority, it will come down to 11001. The correct answer is option A. So this shows what is the utilization of a, why use a constant integer over a macro, because again the same problem revises. This is a macro declaration. So whatever you declare, it will get copied. And the second one is an initialization. Whatever you declare, it will get initialized to. So this is the main difference, and it shows why use a constant integer in case of a C, why it is more safe. Yeah, I'm repeating. So this is a So you have seen a function declaration. So okay, let me little bit describe it in a more detailed way. So one thing is declaration, and another concept is initialization. So suppose we have a function int add, and we say it takes two integers, and then we write the function. The function returns so which of these is, so let me name as 1 and 2. So which one is a declaration and which one is an initialization? Anyone? Which is a declaration and which is an initialization? So this is a very yes, one is a declaration and two is initialization. This is the core thing you need to remember when you are writing a C or C++ uh, like I might mean to say like a code. So initialization, or let me more write it as a definition. So the this so what happens when you compile the code? So whenever the compiler finds this, it copies it here as it is. It doesn't check what is written inside. It will check it later. It first copies as it is. So a similar concept is used in case of a macro. Has defined x 100. So whenever when in any area it finds this, or suppose let me clarify it, x 100 100 plus x. So whenever in the code it finds x, it will just paste it because this is the declaration. So it just pastes it there, and after that it does all sort of stuff. It doesn't check. So a similar thing happens here. So you see when it it says here C1, what it does, it just pastes it here. It does, and in this case this is an initialization. So whenever you are writing like this, a variable, integer variable, it is an initialization, and this is a declaration or definition. So it will just paste this one here. It becomes 10 plus 1. After that, what it is? Into 100. Into 100 remains as it is, into C2. Since C2 is 11, because this 10 plus 1 has been calculated and stored in C2. So it becomes this. So this is the main issue between a declaration and a definition. So in the previous one also same thing. Since it is given like this, it will just copy it here. Both of them has the same issue, which shows why macro is not used. So now understood what is the difference, why macro, what difference between a macro and a constant based integer.
Yes, sir.
Hmm. Okay. Okay, so let's go to the next one. So you have been given this code. What will be the output of this code? So this is the reference. So you need to say what will be the value of this. Okay, so let's so this is the most important thing, that whatever happens here, the value gets updated here as it is. So we have a I which contains 10. Okay, now we say we create a reference. A reference means just an alias. Plain and simple, whatever value stored in I is stored in R, and if there is a change in value of I, it it also gets changed in R. So you notice this, we are post incrementing R. So what will be the new value? That is 11. So the current new value of R is 11. Okay, so it removes it and it stored 11. So whatever now is stored in R is also stored in I, because they are alias. They are same value, same storage location, only they are just different names, I and R. Now we will expand this. So what does mean? What does this mean? So let's simplify it. So this becomes, so if we do this, I equals to R equals to R plus I, then this plus I plus R. So this will be the expansion, right? So what is the value of R? 11. This one is also 11, 11, 11. So it will become 44. Since R becomes 44, I is also 44. So the output will be 44, 44. So let me explain it once again. So suppose you are writing A plus B. What does this mean? A equals to A plus B, right? Now if you write this, so this will become R, R will come here similarly, plus I is here. Now this one is, if this one we translate, it will become I plus R, right? So each one is 11. That will become 44. Since I and R are basically alias, so it will be 44, 44. Is this one clear? You can ask if you have any doubt. Okay, so let's go to the next one. Okay, so you have been given this piece of code. So you need to, so what will be the filling the blanks? Like what we should fill it here so that the output is X. So the output is X. So, so what is this? This is a constant char. So if you need to hold a pointer to this, what will be the type of the pointer? It has to be a constant pointer of this type. So, so if I have an int, suppose a equals to 5, I need int asterisk b equals to a. So I need a pointer of this type, like int type, to store this one's address, right? Now if I write const int a equals to 5, now what, like, if we need to keep it simplistic, you need to remember that we need a const int asterisk type pointer for this one. If you ask me why, let me just say, because here you have a address location. You have a location A which contains 5 and it has some, suppose, address 108C. So this is a constant integer, so this value 5 cannot be increased or decreased, cannot be changed. So as a result, to hold to have this pointer to be held by any like such variable, you need a same constant pointer to hold it. Otherwise, whoever has that pointer can change the value. So to prevent it, it has to be that address can only be, so this address can only be stored in a const type pointer, because it is a constant integer and that value cannot be changed. So as a result, it has to be stored by const type. Now you see which of them are correct. First of all, what is this? Suppose it is saying value at C plus plus. So whatever value at is there at C, that plus plus. So in this case, it will be this one. See, because it is a const character and you are using a const character type pointer. Also this one. same thing. It is a const character type pointer. But this is different. Why? Because it is a pointer to a character type. It is not a pointer to a const character type. This is the major difference between A, B and C. So the correct answer is A and C. Yeah, both A and C is correct. So if you have any doubt regarding this, you can ask. Like when I was a student, I used to remember like this. Whatever the type of pointer, you need to uh, always remember that same type of whatever the value, you need to have same kind of a pointer. So in this case, series is the const char. So then and there you need to remember that you have to store up like the address of that of C. You need a const char star type pointer. Now, if you see the option B, why option B is wrong? Because in this case, the pointer is char type. It is not a const char type pointer. It is a pointer is char type, and that pointer is constant. So what does that mean? Well, that means in this case, CP can only store only one address. It cannot store another address. So that is the difference between A, B, and C. Okay, so if you have any doubt regarding this, you can ask. Okay, so let's go to the next one. So, uh, dynamic memory allocation. So, in C, this is how you declare a dynamic memory. Now, if you have to do the same thing in C++, which of the following is correct option? So what we are doing here? So this basically we are defining a basically an array of 5 elements that is being defined here, that is being declared here. Now this one is not the same. In this one you are basically creating a location which stores the value 5. This one is correct because it is creating 5 array locations. Again same. This one is correct because it is doing the same thing, creating 5 array locations. And this one is not correct because instead it is creating array of pointers. So the correct answer is B and C. Now you have any doubt from any of these question, you can ask. We have I will again start in 1-2 minutes. Which one? Kashish, which one? Oh, C. Option C is same. Like it is similar. Like you see, it is giving size of int. That is, it is creating 5 array locations. just like this. Like these and these are like similar, like definition kind of, you can say. This one is different because it is creating a pointer type array. These are basically definition of memory allocation of array in this case. Yeah, yeah, you are correct. Malloc is a function uh, for memory allocation, like what we say dynamic memory allocation in C. So you understand what is a dynamic memory allocation and what is a static memory allocation? Static allocation. So yeah, I'm explaining it. So when I define something called int a5, what does that mean? It means whenever the program compiles it, like, so whenever the program compiles it, it creates a pool of, it allocates a pool of memory and says that okay, 5 locations will definitely be used in the program. Now this memory location will always be there no matter what happens, until and unless the program stops running. It will always be there. But what happens in case of a dynamic allocation? We do a malloc, say size of int to 5. So compiler does not allocate any memory when it first compiles it. Okay, it checks that okay, there may be one malloc one time. So when the compiler program runs, it comes to this statement. It says that we need a memory chunk of 5. So it allocates a memory out of this. This is a static memory, and this is a dynamic memory. So it takes some piece of memory location from this memory location while when the program needs it. Now suppose I don't need, so suppose you just needed to get like addition of 5 elements, and after it is done you don't need that array anymore. So in this case what you can do is you can just delete this memory. You can just say to the program to please remove this. So there is this command called free, which is used to clean the memory. So the main difference is that while when you allocate statically, this memory remains throughout the runtime of the program. When you do a dynamic allocation, it is not required that it has to be present there for the whole like runtime of the program. It can be for a few operation you can allocate that memory and then take that memory away. You can say that okay, you can take, you can tell the CPU, okay, I don't need this memory anymore, just take it from me, I don't need it. So that is dynamic memory allocation. Now coming to what is a malloc. Malloc is basically a way to allocate this kind of, create this kind of a dynamic memory. So whenever you need such a chunk of memory, you can call this function malloc. It returns a pointer. It creates, like this program, it creates basically an array and returns the first pointer. And similarly, thing is new and new. They are also the same kind of thing. New is for CPP, and for C you have malloc, calloc. Now understood what is malloc? It is a function. In C it is a function. In C everything is a function. When you come to CPP, there are operators also called thing called operator. Any more doubt regarding this week you can ask. Then I will discuss the assignments. Okay, so this week, I know that um, week one and week two's assignment solutions were given. So last week when you were asking that if I can allocate some time for that, like discussing the solutions. So if you have any specific doubt, you can ask, or shall I go for all the solutions one by one to discuss? Whatever you say, I will do. Yeah. Yeah, okay. I will go one by one. So just let me know what is, if you have any doubt regarding that. Okay. Just to, like open your mic and you can ask regarding that. So this was the question number one. This is assignment one. So is the screen visible? Can anyone please say? Okay. So let's start. So this is the first question. So of assignment one. So you have been given uh, uh, this code. So it takes two array. It takes two array. C1, ARR1 and ARR2. So it compares lexicographically both the strings, and the compare function is two lower of C1 is greater than two lower of C2. So if you see here, the first one is C++ and the second one is C program. So you see, since a lexicographical computation, like the second one in this case is C is plus, and the here it is blank. So if you know the ASCII values, ASCII value of plus is greater than ASCII value of blank. So ARR 1 is greater than ARR 2. So as a result, this is the correct answer, and it has been explained here. The same thing. Okay, so this is the reason option A is correct. Now regarding question 2, it is being said like fill in the blanks at line 1 so that the program will print not found. So we have an array that is that contains 1 comma 2 comma 3 comma 4 comma 5, and we need to put something in this binary search so that it prints not found. Okay, so one easy thing you need to understand here is that if we do a search for these first 4 elements where 5 is not present, so it will automatically print not found. So in our case, we will give this, we will search between the first element and the second last element, and it will print not found. And this one is also same, this one will also print the same thing. You are searching between this and this. Can you share this PDF? I guess it has been shared with you, right? There, I guess the NPTEL shared the solution with you, so you will find it. I'm just letting like just going through the solutions one by one so that you can understand. The next question is, you have been given this code, so you have this array and you need to we are doing a sorting, and we need to find out what will be the output. So sort takes start and end. So in this case, start is this one and end is this one. Now when I say end, so it will sort between this and this, right? It will always sort between start and end minus 1. So it will sort between 30, 40 and 10. So what will be the result after sorting? 50, 10, 30, 40, 20. So the correct answer is C. Right. Next, let's go to the next one. Again, you have been given this code segment. You need to find out what will be the output of this code. So you have this thing called rotate. So first one is element, like we are filling out. So this part of the code is basically filling. So it is just populating this array. So it will be 5, 10, 15, 20, 25. Now it says we are rotating element. This is the start, this is the middle, and this is the end. So what will happen? We are rotating up to this. So it will become uh, 25, then 5, 10, 15, 20. Next we rotate up to this first element till this element. So it will become 5, 10, 15, 25, 20. Right. So I explained it last time. So whenever there is a rotate, you always search for the middle element. So middle element in this case is 25. Always remember, middle element will come to the beginning. 25 comes here, and then the rest of the procession, anything that is there. 5, 10, 15, 20. Now next case, we are rotating up to here, and the middle element is in this case this one. So this one will come here, then the rest, and then the rest will go to the back. So in this case, B is the correct answer. Sir, how is it taking element 20 as it is sorting for? Surajit, which, like this is the previous question you are asking. As it is, how is it taking element 20 when it is? Okay, let me check. What did I do? No, 20 it is not taking. It is, I did it only up to this, right? It is only sorting between this and this. You check first element and sort is this actually end my end, and the sort actually takes place between start and n minus 1. What is n minus 1 here? This one. So this what happens between 30, 40 and 10. You check yourself. This will be the sorting. So it will become 10, 30, 40. Understood? Yeah. So let's go to the this one is right, okay. So I know this is little complicated, but I told you the shortcut last week, that always take the middle element to the beginning, then the rest of the cavalry from the front to end, and then whatever is remaining. This is how to do this. Now let's go to this one. So you have a vector. So again, this is an output question. So what you have is a vector of size 3 and all initialized with a. Next what happens? We are doing two pushbacks, and we are pushing uh, C 65 plus I. 65 plus I means B, that is 66, B and C. We are pushing. Now we are resizing it to 10. So now we have 5 elements, we are resizing into 10 and we are giving a default value, that is 90. So in this case 90 will become, 90 is basically Z. So we will add 5 Z's. Now we are resizing it to 8. So only this will remain. This one will be cancelled out. Now this one down, this one down, this one down. Now we are printing it. So this will be the output. That is, in this case, A. Okay, understood this one. This is a vector. So I mean, like last week I discussed like how there like what happens in vectorization. Like you first push it, and when the resize comes, so basically whatever elements are not present. So since it is 10, so initially there were 5. So basically 5 will be blank, and what will the blank be filled out? 90. 90 in this case is Z. So Z will be filled out. Now again we resize it, so to 8. So last two elements will be gone. So these 8 elements will be remaining. So this one will be the answer. Now let's come to this one. So we have been given this string S1 C++ and S2 C++. We need to fill in the blanks so that the output of the code becomes C++ program. So basically this is a string concatenation. You can do it in two ways. This one, C S1 equals to S1 plus S2. Another one is this one. using an append when the last one is getting appended, but you cannot use this one because this is a C function. So see, this, since it's a C function, you cannot use this. Okay, so this one is done. So let's go to this one. So you have been given this code, you have been given this array, so you have been given this array, and we are looping it 1 to 0 to j I minus 1. So if we are looping it for 1, so we are looping it one time, and we are replacing j in this case is 1, and we are replacing j with what should be given here, so that the output becomes 2 3 4 5. Output becomes 2 3 4 5. So that means we need to get 5 here. So this one, what is this one? Data plus 4. So data plus 4 will be here. Now which one of them is giving? This one, because I equals to 0, it loops only for one time. So A is the answer. So let's go to the, so whenever you have any doubt, you can ask me. Just open your mic and you can ask. So now you have this code. You have been given a character array. So this is also an output question. So you have been given a character array, and you have been given two character stacks, S1 and S2. Next, what we are doing, we are pushing the first, like str1 is 9, 9 by 2 4, the first 4 elements to S1. So we are pushing the first 4 element to S1. So S1 has currently 1 2 3 1. S1 has 1 2 3 4, and S2 has I equals to I minus 1. So here I becomes 0 1 2 3 4. I is less than 4, so I becomes 4 3. So here it becomes 4 2 2 9. So we need to, now we are popping from S1 and putting it to S2. So we are popping from S1, so it becomes after this it will be 4 3 2 1, and now we are popping, so it will become 1 2 2 3 4, then this one will be popped, 9, 8, 7, 6, dot 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 4. So it will become this. So this fast for loop will loop over from 1 to 3 4, and the next one will loop over, since we are like here, in this case the I becomes 4, then this loop breaks. Now we come to here, now we are taking 4 minus 1 3, it starts from 3 and continues to 9. It continues to 9 and we are pushing it to stack 2. Now we are popping from stack 1 contents 1 2 3 4, and we are pushing it to stack 2. So this 4 will be the first one to push, then 3, then 2, then 1. At the end, this will be the condition of the stack. Now this loop we pop one by one. So what will be the popped? 1 2 3 4, 1 2 3 4, then 9 up to 4. So 10 elements will be popped. Now let's come to this one. So we have this. So we have this code, I equals to 5, const integer pointer, that is taking this value, that is uh, like we have I equals to 5. Now P holds its address, uh, Q holds also its address. Now R also holds its address and I also holds its address. Okay, so this basically checks which of this statement is correct. So this is a const integer type pointer. This won't this the, so this will so this statement is not correct, because we are assuming that this is a const integer type int and this is a int type, so we cannot change the value using this. Now this one says we are using a constant type pointer to this, and we are saying in this statement that we are changing the value of q, the value that is stored in q, that is basically I. We are trying to change the value of I. This is possible because it is a constant pointer, that means it hold the pointer that it address is stored, that address will not change, except that you can change the value. Similarly for this one is also same, like you notice this one and this one statement, this first statement and third statement are basically equivalent, they represent the same, so both of them are wrong, so this will not be correct. And s is basically a constant pointer to a constant integer, so again this statement is wrong, this cannot be modified, only statement b is correct. So this one basically comes from what we discussed here today, like this part, the same concept. What is the difference between a const char, char star const, char const star char, and const? So if I describe it once more, it will be clearer. So basically, so you have const int star p int star const p int int const star p int const int star const p. So this represents what? This represents the pointer is basically pointing to a location which stores a value, suppose I, where I is of type, where I is of type const int. So this tells that P is pointing to a location which stores I, and I is of type const int. Now this is also same. Is basically we are changing this to, but is also, it also means same, that we are basically, P is basically pointing to a location which stores a value that is of int const type or const int type. Now there is a significant difference with this one. Here it says there is a location I which stores a pointer, which stores a value of int type, and the pointer P can only store this one's address, suppose 1086. So if P's value is 1086, it cannot change. However, you can change the value that is stored in P. Suppose it is in, value is 5 now, you can store this 6. So this is uh, this change is possible. However, this changing this value is not possible. This is the major difference. Next, let's go to the assignment 2. That is the thing which we have completed today. So uh, here we have, so we discussed today overloading and default arguments. So here we have sorry so here we have uh, so here we have few function definitions. So here you have few function definitions, like add. One has takes only one, has one definition, like one argument. It takes two argument. It takes also two argument, and it's also two argument, three argument. Now, so this will give a compilation error due to this and due to this. Since this is a default argument, this one has to have a default argument. Since this two has a default argument, this has also has to have a default argument. We discussed, because once a default argument is given, the rest towards the right, every argument has to have a default argument. So this one is correct, and the other one difference is between this and two. So these also have char, one char, and this one also two chars. So whenever we make a like a call, like add ch, it will not be able to ambiguate between this or this, so, or even this. So this one is also correct, compilation error. Next, what will be the output of this? So we discussed today how macros are a havoc. So what will happen in this case? So this will transform to, what it will transform to? It will transform to a plus plus into a plus plus. So this is a post increment. So this will be 3, and after that it will be incremented, and this will be 4, and after that it will be incremented. So the output will be 12. So option A is correct. Next, this one, which of the lines will give an error? Okay. Okay, so line 1, what happens? So first we have defined a macro here, then we have defined an constant integer I1 which has a value 2, then we have defined I2 which is a value I1. This one is correct because we can define one time. Now what is the thing? I2 is, we are trying to again update the value of I2. Wrong, because it is a constant integer, only once its value can be initialized throughout the program. Then I is equals to I1. Can we change the value of I1? Yes, we can change the value of I. So this one is, because it is a normal integer, so that one is fine. Next is I1 is equals to I. Again not possible, because we are trying to change the value of constant integer. So error will be given for line 2 and 3. Now this one. So what we have here is a we are initializing, so what will be the output slash error, we have to find out. So what happens here, we have a integer declaration a equals to 5, then we are saying, then we are creating a reference of 6. Now 6 is stored some temporary location, and we are trying to take a reference of that. There we are saying this. So this will be an error because we are trying to initialize using some random variable, some random place in the memory that is not defined. Reference is basically an alias, and whose alias? This is a temporary location. We cannot do that. It doesn't allow C. Next, let's go to the
Present, sir. Present, sir. Present, sir.
next. We are going for this one. This one has we have been given a this is a this is again we discussed today, pass by reference and call by reference. So what we have here, x equals to 1, y equals to 2. We are passing a reference of x, so x
Yes,
comes here,
sir.
then it is a reference. So basically we are passing uh, 1 here, and we are updating the value of 1 here, that is I becomes 6, and so the z, and z is also at this point will be updated to 6, and it is also an alias of I only. Next function, next we are passing the value of y, and the first value will be printed as 6 and 6. Next we are passing again x in this case is 6, 6 becomes and the reference is also coming back is x, so value of x becomes now 2, and value of z becomes 2 because it is also an alias of a, so it becomes 2. So correct answer will be a, 6 2 2 2. So this one is similar to the one which we discussed today. Which one? This one which we discussed today. Next we will go for this question. So we have been given this code, and we need to find out what should be given in line 1 such that the output of the becomes 300 and 2000. So we are printing C and D. So one thing is here, we need to pass our reference of C here, right? So line 1 will be a reference, so it will be int ampersand n3, and line 2 we are already passing a pointer, so in this case it will be int asterisk n4, so it will be option B. Now let's go for question 7. So in question 7 we have been asked what will be the output of this code. See, this is one compilation error because we are declaring a pointer, constant pointer, not even a pointer, constant pointer, and we are keeping it uninitialized. That is not correct, that is completely wrong. And second, we are trying to update the value because and it is a constant pointer, so how can we update its value? It cannot be updated, so it will give two compilation errors, C and D. Next, this question, so what will be the output of this? We are printing, what will be the output of this? So we are printing A and X, and we are giving a function this. So the problem with this is we cannot overload using different return types, so this will also give an error. So when we are passing fun, it doesn't know which one to call, and functions cannot be overloaded using just only the return type difference. So this will be the correct answer, that is a error. Now we have been given the following code. We need to such that the program print 5 plus I3. So we need to write something here so that it prints 5 plus I3. So this is a operator overloading statement. So how to do it? So you can do it using, we are returning C2, we are passing C1 and C2, and we are returning only C2. So this one, so since there is a return one, so one has to have a complex operator plus, so one of option A. See, because you are passing you have to pass a reference, so in this case we are passing a reference, and also we need a return type, that is because it is returning a complex type, so complex will be 1, and this is how you have to define an operator overloader. So that ends the MCQ part for this week. So if you have any doubt, you can ask, else it is done for today. We will again meet next week at the same time at 6. Thank you.